All right, everyone, welcome back to our 5th annual Big Give. We have packed our schedule day today so tight. I'm pretty sure we are speaking to somebody new every 20 minutes with zero break in between. So I hope that you're enjoying all of our speakers. As a reminder, our goal is to raise $50,000 to match our board's offer of doing a $50,000 match. So we would have $100,000 to support the Ladder Learning Network. And I think the last time I checked, we were just over $14,000, and it's still early in the day. If you're not able to donate, please like, share, and comment so that it helps our Facebook algorithm so more people can see what we're doing. And I am so excited. I always love talking to Dr. Stormy Chamberlain. You have a way of making genetics make sense, which that's really hard to do.
I've done it for like 25 years or something. So if I haven't got it by now, they should fire me.
Well, thank you for joining us, and tell everyone where you're joining us from today.
Yeah, in January, I left UConn, my cozy nest at UConn, and joined Roche in Basel, Switzerland. So I'm in Switzerland today. I just came from Roche's 125-year party.
Wow. Did you keep saying, oh, we didn't give you your Duke 15 pin? We should just have that everywhere when you go. Well, we're so glad to have you. And I know this time with you is going to go so fast. What are let's just jump right in about common misconceptions when people go to read their genetics report. We were talking about this before we went live, and I think that's a great place to start. What are some of the things people may be seeing on their genetic reports and going, oh, I thought this whole time I was X and our child's really this. So can you touch on some of those?
Yeah. So, I mean, the DU15Q syndrome comes in probably two major flavors. One is what's called an interstitial duplication. And that means that there's two copies of a chromosome chunk, one after another. These are always on the chromosome inherited from mom. That doesn't mean that mom's passed it down per se. It could happen for this particular type, but not always. And again, it's genetics. There's not much we can do about that, right? We clearly have no control over this. So that's the first flavor. The second flavor is an isodicentric chromosome. And this is an extra little chromosome. And so the genetic report will say 47 XX if your child's a female, XY if it's a male, if he's a male. And that's an extra little chromosome that has two extra copies of this genetic region. That's de novo. The words will say de novo, which means from new. It happened in an egg, but once again, it was brand new in that egg. It's not, again, something that's inherited. And so risk of having another child with an Idik is about the same as it was to have one in the first place, which is a nice thing. Whereas the interstitial duplication that I mentioned before, if it's inherited, the risk of having another child can be 50%. So that's why doctors do want to figure out whether there's an interstitial duplication or the extra little chromosome. The other stuff that's on the genetic report, I think, is less important. It might say something like breakpoint 3, 4, or 5. At the end of the day, that doesn't seem to matter so much. Each kid's different, and the different sizes of the duplication, to my knowledge, don't really seem to change a lot about what to expect from your child. Presume competence and help them be the best versions of themselves that they can be. I think that's most of the stuff. Oh, maternal versus paternal is another thing that's on there sometimes. I'm learning that actually many people aren't actually tested for that, to be honest. And it might say maternal, but it's could be a guess. At the end of the day, it probably is important to know whether it's maternal or paternal, but it's a safe assumption that it's probably maternal. And again, we don't do a lot of things differently, maternal versus paternal, but from a science perspective, we're really interested in this now because we're very interested in understanding whether people who have paternal isodicentric chromosomes, or those little extra chromosomes, does that exist? And if they do they look like people with maternal? And that helps us understand what the genes are doing on that chromosome.
Yeah, yeah. It's interesting because we have a few folks who have the paternal on their genetic report, and we often talk about the maternal more than the paternal. Is there anything that you've learned from over the years that really does vary as far as phenotype with the two different ones?
Well, for the interstitial duplication, so the first case where they're next to each other on the same
Yeah.
chromosome, the people who have a paternal interstitial duplication can be fully typical. Or I don't know, that maybe that's not the right way to say it. They might not show up to a doctor with complaints. And so I guess we would call them subclinical, right? It means that they for all intents and purposes seem typical, but we don't know, right? None of us know how typical any of us are, right? But the ones with the kids with maternal interstitial duplications, and then the adults with maternal almost always have pieces of the disorder, okay? And so they almost always are clinical. I'm not aware of any cases, and if there are, it's very, very few, of maternal interstitial duplications that are considered typical. And so, I mean, in my mind, if my child had a paternal interstitial duplication and I thought that they had symptoms of the 15q duplication syndrome, I'd honestly ask to look still for other genes.
Interesting.
So it could increase your risk of having something like DUP15q syndrome, but I'd also look for other potential causes too. That's my perspective. And that said, I'm not a clinical geneticist, so.
Yeah, sure. One of the questions someone just asked is, has there ever been an Idik that's inherited?
To my knowledge, no. In genetics, we never say it's impossible. But when we think about the mechanism by how they happen, it seems really unlikely that it would ever be inherited, right? So it would have to have been in multiple cells during a developing embryo while they were making the eggs, while they were making their oocytes. And it's just a really unlikely thing to have happened in a inheritable way.
Yeah.
Right. And so there are people, though, who have interstitial triplications, which means they have two extra copies, but they're all on the same chromosome. And technically, I think those could be inherited. I also am not aware of one that's inherited. Sperms are really tiny things and they can't pack a bunch of extra stuff. So paternal ones probably don't really exist.
Yeah, interesting. I'm looking at it, and I'm playing tech support because our poor Naka has had her phone go out, her Wi-Fi, everything else. So I'm playing both. You're looking at questions.
So something else that might show up on genetic reports, though, that people might be confused about are the gene names. Those are nice fodder for Googling, right?
Yeah, I know I found myself doing that when I started.
And if you look at them, you will surely be convinced that there's a ton of really important genes on the chromosome. And in fact, we don't really know. We think one gene, UBE3A, is pretty important. In part because, again, maternal duplications seem to cause the disorder, but paternal duplications don't. So that would argue that the one gene, UBE3A, is made only from the copy of the chromosome inherited from mom. So that's the only gene that lives like that. So that's why we think it's important. There are other genes that are surely important. The GABA receptor cluster, as the name implies, they are receptors. They are things that receive an important chemical called GABA, and that's in your brain, and it helps calm your neurons down in general. It's a little more complicated than that, but if there's too much of those receptors, that might cause some issues too. And so each of the genes are probably important for something, but so they're nice to look at, but don't put a whole lot of weight as to what Google tells you about them at this point.
Well, that actually brings me to a question. So if you are a parent that maybe your child's been diagnosed for a while and you're like, okay, now I've over the shock and I really want to dig into the research and understand it. We're outside of our website, which we think is fabulous for resources. where could someone go to understand these basics so that they're not in a Google cluster where they're just, oh, what's true? What can I believe? What advice do you have on that?
Yeah, so like gene reviews is a good resource. I suspect it's probably linked on the Alliance's website. To be honest, I'd go through the literature that's linked on the Alliance's website because that's kind of been curated. As much as I'd like to say that, you know, science is really rigorous and everything peer reviewed is trustworthy, it's not. And so, you know, the Alliance is your partner in helping wade through the pertinent information. You know, that's probably going to be I'd be pretty careful about my sources, right? Gene reviews, the Do15Q Alliance, I'd stick with those for now. If you're brave, you can try PubMed a bit, but there's going to be a lot of information. First of all, a lot of things are still behind paywalls. And second of all, you know, it's in technical jargon. And third, some of it's frankly not trustworthy.
Yeah. And I think that's scary for families sometimes, especially if maybe someone feels intimidated by all of the science. And we have some very intelligent people in our community who can speak science so well that it's good to kind of know. And I have to say too, I think our website has done a great job. We spend a lot of time curating, as you say, to making sure things are accurate. Nika, you're back. What questions do you have from a parent perspective?
Well, I was just going to add, hopefully my mic isn't as terrible, but I was going to add, I worked with Stormy quite a bit a few years ago to create some graphics on Do15Q syndrome, the different variants, as well as the breakpoints and what genes are in there.
Angelman syndrome.
Oh, you're back. We hear you.
Okay, my thing just said power off. Goodness, I'm having the worst technical difficulties today. But the genes that are in the Prader-Willi Angelman syndrome core area. So I'm putting those links in the comments here. So if anybody wants to see them, they've been peer reviewed by Stormy. I just made them look pretty. The other question that comes up a lot, I think, when people are talking genetics, especially with the Idik, is, and I think you touched on this a little bit, if there are multiple copies. So Idik is typically, you have the one piece and it's mirrored on top, but they can have multiples and they can have, extra ends on either side. You're not seeing that that's really making a difference in how they're presenting.
So, I mean, there aren't a lot of examples of kids who have more than 2 extra copies. There are some, don't get me wrong, but there aren't so many that we can say with certainty whether extra copies are worse or not. I think, you know, it's starting to be understood that those with an interstitial duplication are less severely affected in general than those with Idik chromosomes. And I think, you know, I'd love to, you know, take the simplest explanation and say, oh, well, 1 extra copy makes it worse. But we don't know that that's true, to be honest. You know, we probably should figure out how to test whether it's this extra chromosome. Believe it or not, the spatial locations of how these things are in the nucleus in the middle of the cell could make a difference. There are people who have interstitial triplications, and those seem to look a little bit more like Idiks that have an increased seizure risk. That seems to be, in my opinion, the major driver, the major difference between Idiks and interstitial duplications is the seizure risk, although kids with interstitial duplications can have seizures as well. So, you know, more copies is probably a little worse. But again, there are outliers for every statement we make.
Yeah.
That we said that earlier. If anybody says that Do15Q should look like this, every single one of our kids will be like, that's not true. And then we'll make all of us eat our words. It's interesting that you say that about interstitial. So my daughter, she is interstitial, but she has 2 extra copies. And when we had our genetic report, test done, we didn't do the test where you could see if it was Idik or interstitial, just if she had extra. And on the paper, they wrote likely Idik because she had the 2 with an interstitial. And then when I came to the Alliance and I just learned more, I said, well, we should probably see if she's interstitial or isodicentric, and come to find out she was interstitial with these extra pieces. So it's always so unique, you know, even when you say, we say interstitial has one extra piece. There's always exceptions to the rules, especially in genetics. So if anybody's trying to look at their genetic reports and it says you have extra on either end, even though the Alliance website says it should be these, there's always exceptions.
Always exceptions. And furthermore, you know, it's funny. I was talking to some colleagues at Roche about genetics, and I think one of the statements that they use a lot is how rare interstitial triplications are. And I suspect they're far more common than we think. It's just they're not always, you'll get a genetic report that says suspected Idik, and then people don't follow it up, right? And it's not that you should, right? It's not fully necessary to do that, but you know, just to tell you how things written on paper can sometimes be a little bit wrong. So.
Oh, for sure. And I think the only reason our family wanted to look into it more is as I became more active with the Alliance, I learned that it could be inherited. And if I had more children, I wanted to know what type she had. So it was just interesting. The more that you know, the more you can arm yourself with information to talk to geneticists who may not have seen D15Q before. And then that also leads me to talk about the ladder database really quickly. We've been talking about that a lot today. And to say that like triplication interstitial is rare, and it's probably not, we can only know that if our families are putting their data into our ladder database and then sharing that with people like Stormy so that they can look at it, analyze it, and be like, you know what, it's not all that rare. And some of them are having seizures and some of them aren't, and really being able to tell our community what to expect, hopefully by just looking at genetics, but we know it's not that easy.
Well, and I think it's important beyond that because like, you know, of course it tells us more about the disorder, but really these are important building blocks as I'm learning here at Roche, right? That they're really important building blocks for companies that are developing therapeutics to start, right? If you have that, you know, I can make the argument, well, we should work on Dup15q because look at all of these pieces that the patient advocacy groups have put together. And in fact, disorders with less well-organized patient advocacy groups and with less data are harder to study, harder to work on from a pharmaceutical perspective. And so it really is critical to helping companies develop therapeutics for the disorder. So it's a super important thing to put data in ladder database. And I love it that it's I don't know, I like to think it's kind of real world data, right? It's collected in the course of a medical exam rather than a research visit. So.
Stormy, I'm curious before our time's up, I knew this would go so fast with you. What research are you most excited about? What therapeutics or what can you share with us that you're like, that seems promising for Dup15?
Yeah, I mean, I'll be biased and tell you that the paper we published recently with Eric Levine's lab, and I understand you'll talk to him later. I think that's super exciting. We've reduced UBE3A in Idik 15 neurons, and actually we did something really cool. We asked the Idik chromosome to leave. We didn't ask nicely, we asked it kind of rudely actually, but we asked it to leave and it left. And so we have identical twins with and without the Idik chromosome, right? And then we reduced UBE3A in the Idik one and asked, does it become more like its neurotypical identical twin? So I'm very excited about that work because I think reducing UBE3A might be really important. But I've also learned about, I think Roche has a clinical trial coming up that I'm kind of interested to see how that works as well. And I'm very enthusiastic about that. There's a lot of cool science behind it. So, you know, as I learn more, it's kind of crazy. You've been working in a field for so long and you still learn more that you're super excited about. And then you learn things like, I think Ben might talk about a mouse model that might say something a little different about UBE3A. And I really want to understand how these two things work, right? So the stuff I get excited about are figuring out this puzzle, largely because I think that once we figure out the puzzle, we can better turn that into ways to help your kids, right?
Yeah, that's exciting. I think that we've talked a little throughout the morning of just giving our families hope and letting them know that like there's so much more. I mean, you're across the world right now and you're working on things that pertain to our families. And I think it's so exciting to show that there's so much going on. And also the importance of the Alliance. Like I love that you threw in the importance of having a strong advocacy group backing up the families, not just one parent calling you going, hey, I need some help. we've got a whole group of us coming and say, we need your help in doing these, changing the therapeutics. Yeah.
Don't underestimate the power you guys have, though, on organizing clinical centers of excellence, right? These are places where clinical trials can happen. This ladder database, again, is so important. And, you know, without the Alliance and the Angelman Syndrome Foundation, that wouldn't exist, right? And you have to have people that organize this effort. And it's super important for therapeutic development, and it'll be important for understanding the disorder as well. So the Alliance is doing great work, and I hope that you guys can share your secrets with folks overseas and stuff, because I'm learning that it's more difficult for European patient advocacy groups to get off the ground, and I think they could certainly use some help there too, or an example to follow.
Yeah, absolutely. Well, we appreciate so much what you do. Your name is mentioned with such regard in our community, and your passion for our families is so appreciated. So we thank you so much. Thank you for what time is it where you are right now?
8 p.m.
Oh, so it's not like 3 a.m. or anything. I should have looked at my world clock before what time zone you're in. So thank you so much. Neka, is there any final words that we need to close up on?
No, I just want to let everyone know that the research that Stormy was talking about, we just put that in the comments below. So you can click on it. It's called the Role of UBE3A link. And that is the most recent research that she was talking about on the website and in the comments. So if you have any questions, throw them in there. I'm not sure we're always going to be able to get a hold of Stormy to get the exact answer for you, but we sure will try.
Oh, I'll always answer. So keep sending.
Oh,
you're sending.
So great.
We got it.
Neka, I also just put the laddertotreatment.org in case people don't know what we're saying in the comments, so that we can make sure, again, if you're a DUP15 family and you are not in ladder, it will take less than 1 minute just to sign up. And then that helps our numbers, and they're growing today, which is so exciting. I'm watching them move up, which is honestly as exciting as the fundraising dollars are. This is so incredible watching this grow. So thank you. All right, what do we have next, Neka?
I don't know.
That was supposed to look so smooth, like we had a script.
No, I'm trying to get my mics to work, my internet.
I'm just trying to survive this right now.
A hot mess
We
over here.
actually have Dr. Alicia Holliday from Autism Brain Net coming up, and we're going to talk a little bit of a tough subject, but something that we will talk about how to even talk about this with your physician. So join us in a minute as we talk to Autism Brain Net. So thank you so much, Dr. Chamberlain. Thank you for what you're doing.
My pleasure.
Thank
and hi to all my friends out there.
Oh, that's great. Thank you.
You in
Take
August.
care.